Assalamualaikum dan salam sejahtera. Anda sedang menonton Sudut Pandang dan hari ini saya gembira kerana saya ada seorang tokoh yang cukup terkemuka, pemenang hadiah Nobel 1999 dalam bidang fizik untuk bidang partikel fizik, subatomic particle dan sebagainya, Profesor Gerardus at Hooft. And now I would like to ask permission to speak in English. Thank you so much, Professor, for being with me today.
It's my pleasure.
And you're a Nobel winner, but you're here in Malaysia to talk about peace and bridging divides and dialogue towards a culture of peace. And before I go to the bridging part, it would be good to introduce you to our viewers. A lot of people look at Nobel winners as very distant, but actually when I went to Stockholm for the Nobel ceremonies, most of the scientists are very easy to talk to. And in Malaysia, there's still this perception that scientists are aloof and it's hard to pinpoint. But in Holland, for example, you know, you have scientists as grandfathers and granduncles, and this trickle down to the next generation. Do you think scientists are born and not made, and you must have good pedigree to be a scientist?
I think it's a very complex question whether scientists are born or made. I think it's a bit of both. In my experience, I think I was, in a sense, born as a scientist. Already as a very young kid, I was interested in how nature works, how water flows from high to low, how wheels make movements very smooth, and things like this. And I was curious from a very young age in all sorts of questions that most of the other kids of my age were not interested in. And on the other hand, I also had an environment of people around me who were interested in science and who were fostering my curiosity such that I could become a scientist.
Your granduncle have a big influence on you? He was a
great
scientist.
My granduncle was already very old when I met him first time. So his legend was more important. He was a Nobel Prize winner, and he had made an important discovery in physics, which turned out to be very important for biologists. It was a new kind of microscope that he had discovered.
Your field is theoretical physics,
yes,
and at the University of Utrecht. And can you explain about the importance of studying particles of atoms? Why is it important for our life today, for example?
It's one of the very basic features of nature that you're studying. You are trying to figure out how things work, how things work at the tiniest possible distances and sizes. So imagine large things to be made out of small things. A house is made out of bricks. The bricks are made out of little grains of clay and so on. And those in terms are made out of atoms. And those atoms are made of other things, and you can continue that way for a while. And you discover that actually everything in principle is controlled by those very tiny particles which make up atoms. And if we understand their behavior, we understand why they can make atoms, why you can make bricks out of them, why you can build a house out of that. So if you're interested in such questions, you should also study the basic laws of nature.
Technology advancement has given scientists a lot of new tools to achieve a greater achievement, for example.
Yes.
Like the Large Hadron Collider, for example, you are very familiar with CERN. Can you share with us some important breakthroughs that are hoped to be derived from that particular groundbreaking experiment, for example?
Yes. You have to understand that the prize-winning work which I did in the 70s, late 60s and 70s, was about the subatomic particles, the particles which make up the atom inside. Particularly, the nucleus of the atom contains many particles which interact in a very complicated way, and we managed to shed new light on those interactions, how to make them understandable, and how you can compute things. And this, during those subsequent 30 years, led to what we call the Standard Model. A model is basically a description of things you understand in books, in equations, and so on. Standard means that this is all we really think we understand and we know for practically for certain. Today we have a standard model that explains all the particles we see very accurately but at the same time we know it cannot be exactly right. It is mathematically not totally consistent. There are deep difficulties, but they are very deep within. If you go to very, very tiny distances, we no longer believe that our standard model, our standard understanding is correct. There must be more. And the search is now for what is it that there is more. Is that in the form of new particles, new interactions, new principles of nature? We want to know all this. And the only thing to find out is do new experiments. Now, what's stopping us from doing these new experiments? They're costly and they require the utmost of technology. We want to have the fragments of atoms collide with as much force as we can put in them. So we want these particles go as fast as possible. Well, they can't go faster than light, but you can put lots of energy in their motion by pushing them harder. And with lots of energy in their motion, they collide. And what happens at such collisions is controlled by their very tiniest constituents. So by having particles collide as fast as we can discover their properties. And LHC is now a new machine which has just been completed in Geneva, which will attain a new amount of energy which has never been reached before. The machine is not yet properly working. There has been an incident which damaged it during construction. So we're still waiting for those damages to be repaired, and then the machine can be switched on. And we will, during a number of years, experiments will be done to improve our understanding of these parts.
I have to go for a short break, but when we come back, more about our Nobel Laureate and also how education and fundamental science can bridge divides between nations. There's a lot of nationalities and people from different backgrounds as scientists and as physicists that works together for LHC, for example. And maybe that's why Nobel laureates and scientists like you are chosen to come to Southeast Asia, for example, and to talk about bridging divides, because scientists looks at facts and truth, for example. So do you think you have more authority to talk about bridging divide because facts and truth are the key?
I didn't ask that question. I was asked to come here to talk about bridges between nations, and I thought, well, science is a very important bridge. The truth we're trying to figure out is not bounded by borders between nations. The atoms in Malaysia are the same atoms as the ones in Geneva and the ones in the United States. So investigating those can be done by anybody. You're not restricted by any nationality. And in fact, CERN is officially a European machine. There are 20 member states all from Europe. But well, the hope is it might grow into a world machine. There are many other nations from outside Europe already participating in the whole endeavor. But it could become even more a world machine if these other nations would contribute even more. And so building these very large devices which investigate scientific issues acts as a bridge, because when we join forces, we have many nations working together in these laboratories, they're all after the same truths. They realize that the truth here is not different from the truth there. No point in fighting. You work together, you collaborate, and that's of course very conducive to peace. So this is why I said, well, wait a minute, if there's a conference here, or if there's something to be said about peace between nations, I think science is something to mention here, to report about. Doing science is a very peaceful thing to do, in particular the kind of science that I am doing, which is discovering subnuclear particles.
I read your speech that was presented, and you say differences are good. That's
Yes.
the basic of science, actually, because it helps you to find answers and evolution.
Yes.
But however, nowadays, maybe in the world today, people keep looking at differences as a divide. And for example, if we talk about LHC or Nobel Prize, developed countries scientists or Western countries, the scientists would be much more advanced, hence they will be the one getting new knowledge and all that. How do you think developed countries should approach that particular perspective?
Well, I think there's a false sense of modesty. Scientists from developing countries are exactly as intelligent as scientists from the West. There's no difference. Maybe their background is different, maybe their cultural background is different, but their intelligence is the same. So what people in the West can do, any scientists from developing countries can do as well. So of course you need skills, you need training, and often the opportunities are not there in developing countries. So it means that you have to intensify contacts with the rest of the world, in particular the Western world, to train the people here and to make them acquainted with the most urgent scientific problems. You can do experimental physics, well then you have to go to big laboratories, which are not plentiful here in this part of the planet. But you can also do purely theoretical results, where today with the internet you can contact everybody, anywhere, about theoretical questions. So there's no reason why that work should not be possible here or anywhere else in the world.
Developing countries has this dilemma now. In the world of commercialization and marketing of products and services, sometimes you want to give the limited resources that you have to applied research for direct results for commercialization of products and services, for example. But you have been known to say that fundamental research is very important too. And,
Right.
We might be still looking at the colors of candles instead of electricity if we were looking only at the other side, for example.
Exactly. In other words, applied science is important, and nobody will deny that. And I think it's a very important feature of science that it can be applied and it changes our life. Our life has been changing beyond recognition by the discoveries of science. But science is interesting and appealing, particularly to the youthful people, by doing the more extreme forms of science as well. Think of space science, think of indeed elementary particle physics, where the applications are not so clear, and we are not doing particle physics in order to get applications, although there are always discoveries made which can also be applied. In fact, the World Wide Web is a direct consequence of scientists who were collaborating across the borders and needed a fast computer connection. And the World Wide Web grew out of that, so which is now changing our society again. So this is the way science works. We are interested in very fundamental questions which are very far away from being applied, but on our way we make many discoveries, and many of those can be applied. Scientists today need faster computers than anybody else in society. But once you have those fast computers, people discover all their useful applications elsewhere.
I read an interesting quote on your speech too, where you say, if you can afford to buy the latest in weaponry, for example, the most expensive helicopters or guns or whatever it is, why can't you do the same for science and really invest that amount of money, for example, into fundamental research, building institutions and giving training or bringing in expertise from outside? Do you think that is the basic and there's no shortcut in that particular way, that we must do that to achieve a high level of science?
Yes, just referring to military application of science, we see enormous amounts of money being basically wasted on weapons, but those weapons are based on very advanced scientific methods, often indeed applied science, but very advanced science, made by scientists who are interested in everything in this world, of course, also in how to make weapons, how to make devices. So if if you're interested in all that, you should also be interested in pure science itself. And I advocated in my talk that you should not neglect pure, not only unapplied, but inapplicable science. If you want to play part of the game in the entire world. And Malaysia has proclaimed that it likes to have a Nobel Prize in the near future. Well, you better then concentrate not only on applied science, but also on fundamental and pure science.
Do you think we should, establish institute like your own institute for theoretical physics, for example, and look at various ways that we can bring in maybe expertise from outside? Is that a good way to start?
Absolutely, yes. So, yes, theoretical physics is one aspect of science. It has many applications even beyond physics. Often theoretical physicists find jobs in industry or in banking or in statistical research organizations. So you can apply the skill that you obtain by being a theoretical physicist in many different ways.
Time for another short break, but when we come back, we'll ask more from Professor Gerard at Hooft about how science and fundamental science, for example, can bridge the divide between nations. After your speech, there's a lot of questions from the floor, and I'm sure there's even a question about Constitution of Malaysia to you. But one of the questions that I have is, in Malaysia at this juncture, we're still thinking about whether we should teach English and maths in English. We should teach maths and science in English, for example. But you have been known to say that if you learn as many languages as possible, that's even better, because you can speak to a lot more scientists and know about a lot more knowledge.
Well, I should make that a bit more precise. It was like that in the beginning of the 20th century, when science was still done in many different languages. Important science papers were written in German, in French, in English, and even in Dutch. And so if you know all those languages, you would have an advantage situation. Today, practically all of science is done in English. So now life has simplified actually because of that. Now you only need to learn one language and you can basically follow practically everything in science. You just learn English. And so you can start early enough with trying to master the English language. I would have wished it were Dutch rather than English, but well, no, they chose English to do in science. Well, you have to learn it.
Add the internet to that, and you have a bigger reach all across the globe with convergence of knowledge. Scientists can remain where they are.
Yes.
They can exchange information. Do you think the explosion of data at the speed of light, for example, will really give a new face to scientific discoveries?
It already has done that. Science is spreading very, very fast. Nowadays, when people write a new paper, in particular in theoretical physics, they instantly put the paper on the internet, and within half an hour the entire community can download your paper, and the knowledge has spread across the globe. It wasn't like that 30 years ago. The papers often took half a year to cross the Iron Curtain. And so this is an enormous improvement in the dissemination, the distribution of science results. So science now progressing even faster.
I'm sure as you fly across Asia and mix with the community, you notice that sometimes there are some people who think that advancement in science have conflicts with the values that we have, whether it's religious or cultural. So how would you solve this perception that advancement in science, for example, and the pursuit of science would somehow be in conflict and clashes with the values that we have in Asia, for example?
Well, it's a bit inevitable that, well, science enormously enhances, say, globalization, and science indeed gives you other values than the traditional religious ones. Now, it depends on how you are looking upon the many religious issues and how religious you are, whether or not you say, well, I stick to my religious feelings, I don't want those to be affected at all by any scientific finding, or you could say, well, wait a minute, those scientific findings are much more interesting and they seem to be more accurate in describing the truth than what I could infer from my religious ideas.
Do people ask you that question?
And I think that sometimes people say, well, this affects my religious belief, my view upon the world, but not in a bad way at all. It enhances my understanding. What is wrong with that? And we say, okay, it affects me, it affects my view of the world, but in a good way. So I don't see there's anything wrong with it.
You're an expert in mathematical models too. You know, of course, maths is very essential to your work and to physics. And there's this view that maybe in the distant future, there'll just be one equation that will explain the being of the universe. You know, the Big Bang and everything else. And do you think that will happen?
People speculate a lot on this possibility, that maybe all of nature is captured completely in one equation. And this is conceivable. In fact, I believe that this might well be the case. It's quite possible. It'll take a long time for humanity to discover this equation. A few decades ago, in 1984 to be precise, people made the discovery of a new kind of theory which made some of us believe that we will be very close to presenting that, precisely that equation. And people are very hopeful that maybe even before the turn of the century that the equation will be discovered. This did not happen. And I've been one to say, no. The equation might exist, but it's not this. And you're not anywhere close yet. And I think I'm right now again, that we haven't come close to that equation yet. But I have enormous faith in human ingenuity. And I think people will, if it's there, somehow people will find it.
Yeah. I have about 1 minute left. What do you think is the most important role of science now in view of the great challenges that we have? For example, global warming and adaptation to the changing climate.
I think science is the only way to solve those, to address those questions and to solve them. Yes, there will be climate change, and there are important problems with energy production, food production, population growing, the question how to control population growth. All these are scientific questions, and my belief is science is the only way to address those questions, and so we have to invest as much as we can into science. But these are, of course, advanced sciences. So yes, you have to do applied science.
Do you think that scientists all over the world, and not just scientists, everyone else has got to sit together, forget the differences, and find a solution?
Yes. So, for instance, Al Gore himself, not a scientist, but he did his contribution by producing this famous movie, and where people are confronted with at least the question, whether he addresses the question correctly, whether he presents the facts correctly. You might argue about it, you might argue about details, but the problem is there, and people should be thinking about the problem, and that was a good thing. So, so that's a way you can contribute. But I think eventually scientists should find out. First of all, they have to find out the truth. You know, how is climate change caused by human activities? To what extent? Maybe not at all, but most people think it is caused by human activities. What are the options we have? The reasonable options, not the futuristic options already dogmatic options. That's not going to work.
Thank you so much, Professor. That's all the time I have for tonight. Thank you so much for coming to Malaysia and sharing knowledge with people in our universities, for example, and also the public, because the series, the Bridges Dialogues Towards a Culture of Peace, is actually a forum that you can go to. It's open, there's no charge, there's no admission fee, and this series will be ongoing. It will be featuring a lot of Nobel laureates and some other well-known, eminent people around the world coming to Malaysia from November this month right up until April of next year. Thank you so much, Professor Gerardus at Hooft, and thank you to you for watching Sudut Pandang, and we'll see you some other time. Thank you.